Okay, so this is question 3. You're trying to evaluate this integral f dr, where f is this, and c is the curve, and they give you the curve. Now, first of all, if you see this question to integrate, and you see that the curve is very complicated like this, first of all, you need to test if it's conservative or not. So, test to see if the function conservative. So you have the I, the J, the K. So this times the function d dx, d dy, d dz. And you have 2x z y sine x, 1 plus cosine x, x squared 2z. And I showed you in the previous question how to do it, hoping to see it's 0. In fact, if you do this, it would be 0, 0, doesn't matter, and 0. Simply because it's the same function. So the one given in question 3 is same as the one given in question 3. So you can say from question 2. So this function is conservative. So now you can think about it. If you're integrating this, you have to go 2xz, so 2 of this times z te cubed. And then y, which is t plus 1, sine x, which is the sine of this. You'll see that it's too much. In fact, there is no way you can integrate it. But there's something about conservative functions. You can say this. Since the curve starts and ends 0, 0, and is conservative, the integral would equal 0. So you don't need to do anything special. Since it's conservative and it starts and finishes at 0, then the integral would be 0. Okay. Now question number 4. Question number 4, use Green's theorem. So we're going to use Green's theorem to evaluate the integral 2y sine inverse x 3x squared tan y dy around the path starting at 0, 0 along the x-axis to 1, 0, then along line x equals 1 to point 1, 1, and then along the line y equals x back to 0, 0. Okay, I'll try and simplify this. Since they want you to use green theorem, the part that has dx, we're going to call q of xy, which is 2y sine inverse of x. And then I'm going to find the derivative of this with respect to x. 2y doesn't have a derivative, and the derivative of this would be 1 minus x squared 1. The part that has y, I'm going to call p, which is 3x squared tan y. And I'm going to find the derivative with respect to y. This is 0. This is secant squared. So we have the derivative with respect to x and the derivative with respect to y. Now, the rule says if you want to integrate this, I'm going to write my qx here, just trying to create some space, and my py secant squared. So, the rule says you need to integrate qx minus qy dy dx. But to actually integrate, we need to know the limits. What are the limits for y and what are the limits for x? Now, they tell you the path, so if I draw my y, x and y axis, you start at 0, 0. Along the x-axis till you reach 1, 0. So this is point 1, 0. So you go this way along the x-axis till you get to this point. And then along x equals 1, you go straight up till you go to point 1, 1. So you go straight up along the line x equals 1 till you reach this point. And then you go along the curve y equals x, which is this line, you go back to point 0, 0. So you go this way. So, you know that this curve here is x equals 1, and this curve here is y equals x. If you draw a rectangle, a small rectangle here, and that would be dx, the top point would be y equals x, and the bottom point would be 0. And that means for dy, you're going to integrate from 0 to x. Because again, the top point is x, the bottom point is 0. And the limits for x is 0 and 1, because in x starts from 0, finishes at 1. Qx is minus 1 over 1 minus x squared, and this one is secant squared y. We're going to integrate this dy first, and then dx. I'm going to erase some of this. Now, the integral of this with respect to y, since this is all constant, it would be this whole thing times y. And the integral of this with respect to y would be tan y. We're going to plug x and 0, and then integrate the results from 0 to 1. So you plug x, it gives you x over 1 minus x squared. X here gives you tan x. 0 into y gives you 0, and tan 0, which also 0. So now I know that I need to integrate from 0 to 1 this and this dx. This one I can write as x 1 minus x squared to the exponent minus half dx, or let's do it one step, minus tan x dx. This one here could be done by using u sub. So I'm going to go here and say, let's integrate negative x 1 minus x squared to the minus half dx. I'm going to let u be the inside. Du would be minus 2x dx. Get rid of the 2 minus x dx. So the inside is u, so u to the minus half. Negative x dx would be du over 2. Sorry, du over 2, which is half. The integral of this, you add 1 to the exponent, you divide by the exponent, cancel, cancel. So the answer is u to the half, which is this to the half. So the answer would be 1 minus x squared to the half, which is basically just a square root. Anything raised to a half would be a square root. And the integral of tan is ln absolute value of secant x. It's one of those that you're allowed to memorize. So you need 0 and 1. So you plug 1, that gives you root 0. You plug 1, it would be ln of secant 1. You plug 0, that's root 1. You plug 0, ln of secant 0. Of course, ln 0 is, square root of 0 is 0. Secant 1 is not famous. It's not one of those that very common, so just leave it as it is. So this is 0. ln secant 1. Negative square root of 1 is 1, so minus 1. Minus minus plus ln of secant 0. Now, if you have a calculator, if you try to figure out secant 0, in the calculator, do cosine 0 or 1 over cosine 0. So secant 0 is 1 over cos 0. And cos 0 is 1. So this is 1. And of course, ln of 1 is 0, so the answer is minus ln secant 1 minus 1. So this is the answer for this question. There is one more question for finding surface area, question 5. I'll do it here. I don't think we need to do it in a different part. So question 5. Find the surface area. So you're trying to find the surface area of the part of the paraboloid or paraboloid z equals x squared y squared that lies under the plane z equals 9. Okay, when they say find surface area and you have a function in terms of x and y and z, the rule is the integral. You put d here. D would be the dimensions, basically. 1 plus the derivative of the function with respect to x squared, the derivative of the function with respect to y squared, and the dA. We'll leave it as dA because you might do it as it is, or you might need to switch to polar. We'll see. Now we start by applying this. So we have the z here. We need to find the derivative with respect to x. 2x and 0. We find the derivative with respect to y. 0 to y. So now the square root becomes this here squared and this here squared. This is 4x squared, 4y squared. And you'll see that 4 is common, so I can write this as 1 plus 4 brackets x squared y squared. So I'm going to erase some of this to show you what we've accomplished so far. Surface area, integration, under the square root, we have this. And dA. So, if you can do it dx dy, but you'll notice that it's too much. And anytime you're doing, you see x squared plus y squared, that's usually an indication that you need to switch to polar. So converting to polar. So r squared is x squared plus y squared. And dA, when you switch to polar, would be r dr d theta. So, to figure out the dimensions for r and theta, let's start with r. Since they tell you z is 9, so I know now z equals 9, then r squared is 9, then the radius is positive negative 3, so radius is 3. Meaning that this integral becomes, watch, in terms of r, radius starts from the origin till reaches a height of 3. For theta, we will consider a complete circle. One plus, instead of x squared y squared, I can put r squared, and the dA, as I told you, you put r, that's dr d theta. So this is the integral we need to work on. So I'm going to erase to do the integral. I'm going to turn this into power half, and as you know, this is done using u sub. U would be the inside, du would be 8r dr, then du over 8 is r dr. So it's like integrating u to the half, r dr would be du and 1 over 8. This would be 3, 2/3, 1 over 8. 2 and 8 becomes 4 in the bottom, so it's 1 over 12 u 3 over 2. So the answer is 1 over 12 u, which is 1 plus 4r squared to the 3 over 2. And this is the integral for the first one, where we need to plug 0 and 3 and then integrate from 0 to 2 pi for d theta. Good? So I'm going to erase this. Now let's plug. 3 squared is 9. 9 times 4 is 36, plus 1, 37. So 1 over 12, 37 to the exponent 3 over 2. Minus, plug 0, it becomes 1 to the 3 over 2. You're still integrating this d theta, and it's still from 0 to 2 pi. You can read this as square root of 37 cubed over 12. 1 to any exponent is 1, so this is minus 1 over 12. Or you can just, since they both over 12, you can write it as one fraction. So the root of 37 cubed minus 1 all over 12, and you start integrating this d theta. That's a constant, and when you integrate a constant, it would be 37 cubed minus 1, 12 theta. You plug 2 pi, you plug 0. Plug the 2 pi, minus, and the 0 will give you 0 everywhere. You can cancel the 2 with the 12, make it 6, so it would be final answer, the root of 37 cubed minus 1 over 6 4 5. This is the final answer for the question. Now, you guys asked me for review. I don't have any old exams, that's the problem. So, and I think Fendon, this is what he'll do, considering all the circumstances and the situation. I think he will basically do the worksheets or questions similar to the worksheet. So, you need to review all the worksheets, all the videos that I did for the worksheets, especially the ones 6, 7, 8, 9, 10, and 11. Plus the main ones, the first ones. The first ones were part of the midterm, so I don't think, I mean, reviewing them should be easy, but the last 6 or the last 5, I don't remember if worksheet 6 was part of the midterm or not, but the last 6 or 5 worksheets, I have the videos for all of them, review them, and if you have any questions, you can let me know. And good luck.